I'm more nervous for this interview than probably any interview I've ever done, just with my own daughter. So this is, we're doing this in part because we're at your school, and the Carnegie Mellon Carbon Intensity Index is something that Carnegie Mellon has sponsored, and then we're doing it in part because it's Bring Your Child to Work Day, and we sort of thought about how in the world does a CEO bring his child to work, and so instead we brought me to you here at the university.
You came to my work.
I came to yours, that's right.
Dad, I was wondering if you could explain what the Carnegie Mellon Carbon Intensity Index is.
Well, the Carnegie Mellon Carbon Intensity Index is something that my company, Mitsubishi Hitachi Power Systems, is sponsoring. And the reason we sponsored it is that we want to make sure that a really important message is getting out there to the general public, which is that the carbon intensity of power generation in the United States has fallen dramatically over the last 12 years or so. Everybody, rightfully so, is very concerned about climate change, and sometimes I think we feel like the world's not making any progress. Here in the United States, in the power sector, we've actually made a lot of progress, and we asked Carnegie Mellon, as an independent research institute, to go ahead and study that, and then put out this report on how the U.S. is doing in the power sector in decarbonizing it.
And why are things changing?
Well, what the folks at Carnegie Mellon reported in this first press release, since 2005, the carbon emissions from the U.S. power sector are down by 23%. And that's a pretty remarkable number. It's something I don't think a lot of people realize. And then furthermore, they went the next level down and they said, so why is it down 23%? So one reason is the overall carbon intensity, which is the amount of carbon per megawatt hour of electricity produced, that's dropped 24%. So if you produce a megawatt today versus 2005, it emits 24% less carbon dioxide. The reason the total emissions are down by 23% is because our electrical usage between 2005 and today has been pretty constant. So, for about the same amount of megawatt hours, we've reduced 24% in intensity, which is 23% in total emissions. And then when they break that down, they say, so why is that happening? To answer your question, 53% of that reduction is because the United States has been switching from coal-fired power generation, older, 30, 40-year-old inefficient coal-fired power plants, to natural gas-fired power generation. And there's less carbon in a methane molecule than there is in coal. And so you get about a 50% reduction just because there's less carbon in methane. And then furthermore, a natural gas power plant is more fuel efficient than a coal-fired power plant. So you actually get about a 65% reduction from a modern natural gas power plant versus an older, inefficient coal-fired power plant. So 53% of the reason is that switch from coal to natural gas. 4% of the reason is just the natural gas power plants are getting more efficient. So 53 plus 4 is 57%. And then 40% of the change is because there's more renewables that have been built out since 2005. So, basically the whole story is that in the United States power sector, we're switching from older, inefficient coal-fired power generation to a combination of efficient natural gas and renewables.
And is that the same story worldwide, or is that a U.S.-specific story?
So it's specific to the U.S. In one way, which is that we have a new abundance of natural gas in the United States that's due to new drilling technologies, which has dropped the cost of natural gas from, it was about $7 a million BTUs a decade ago. Today it's less than $3 a million BTUs, which actually makes it cheaper than coal. And so there's a real economic driver to switching from coal to natural gas in the United States. That same driver doesn't exist in some other parts of the world. For example, in Asia, where they have to import all their natural gas, natural gas there today is about $12 a million BTUs, and it's actually cheaper to burn coal in Asia than it is natural gas.
What do you think the power plant of the future will look like?
What's being sold right now in the United States is this combination of really efficient natural gas and renewables, and that's displacing some older, less efficient coal-fired power generation. What we think the power plant of the future is going to be in the near future is more of the same. More natural gas power plants along with renewables replacing older, inefficient coal-fired power generation. If we look out beyond that, we're really starting to concentrate on the idea of dispatchable clean power, the idea that we need to have clean power sources that remove the problem of intermittency that we have right now with renewables, or clean power sources that remove the problem of carbon emissions that we have right now with fossil fuel power generation. And so that means either renewables plus batteries, or it means fossil fuel power generation with carbon capture and sequestration. And the reality is we think the power plant of the future is probably going to be some combination of both of those.
What do you see as the place for engineers in the energy sector, especially for engineering students who are my age and a little older?
For an engineer who's a freshman in college like you, I think you're just starting to learn these tools. The more that you can turn what you're learning into ideas and turn those ideas into reality and just practice doing that again and again and again, no matter what you end up doing with your engineering degree, that's great training and great progress to get you ready to go, change the world.